Hey guys, in re-listening to some of my videos surrounding B cell activation and differentiation, I realized there were two concepts that I didn't really cover that I want to make sure you understand because they're both actually pretty important to the function of the B cell. The first one is cytokines. I say in the notes over and over again that cytokines direct the antibody response that is made, but I don't really talk about how that works. And at this point in your curriculum, you don't really know yet how incredible cytokines are. Cytokines are the ingredients to an immune response recipe. If I'm in the kitchen and I take chicken and cilantro and avocado and sweet corn, I'm going to get one meal. But if I take chicken and tomatoes and onion and Parmesan cheese, I'm going to get another. But there's still chicken in both. And the same is kind of true for cytokines. If I take IL-2 and interferon gamma and TGF beta, I'm going to get one response. And if I take IL-2 and IL-4 and IL-10, I'm going to get a different kind of response, but there's IL-2 in both. So we're just going to begin to scratch the surface on that. And we're also going to introduce another type of CD4 positive T cell. And that is the T follicular helper cell. This is a specialized T cell that lives within the follicle in lymph nodes. And that's really important because the follicles are where the B cells are. So if we're expecting the B cells to get help, we better have some T cells to help them out. So let's start with cytokines, okay? So when I talk about the concept of class switching, I'm literally talking about after a B cell has been activated. So remember, originally, if I just have a B cell here, the B cell receptor on the surface is IgM, right? Once the B cell becomes activated, it's going to become activated because of two things. One, it saw antigen. The other thing that's going to happen is that the B cell, upon activation, is going to upregulate expression of CD40, okay? And the T cell is going to upregulate expression of something known as CD40 ligand, okay? CD40 ligand is going to turn on expression of AID, the enzyme in the B cell that actually makes cuts in the genome to allow for class switching. And class switching means we're going to go from IgM to either IgG, IgA, or IgE, okay? So I go through the process in the notes. The main thing I want you to know is that it's AID mediated and it doesn't happen without CD40 ligand interaction. Now, that's only part of it. The other part of it is that we need cytokines to inform should it become IgG, IgA, or IgE secreting plasma cell. And that's what this table is kind of showing you. So depending on the cytokine that is the predominant cytokine at the site of this interaction over here, so what's the majority of that microenvironment made of, is going to tell the B cells in the area what type of antibody they should make. Each B cell can only differentiate into a plasma cell that can only make one type of antibody. So you're never going to have a plasma cell that makes both IgG and IgE, right? But if there is a lot of IL-4 in the area, some of the B cells are going to begin making IgG, and some of the B cells are going to begin making IgE. And you're probably going like, okay, but how do they decide which one to make? Good question. An immune response is never mediated by a single cytokine, okay? So while IL-4 can drive either IgG or IgE, whether or not it goes to IgE or IgG is dependent on what other cytokines are there and in what doses, okay? So if we go back to our cooking analogy, do I want to add, if I'm making guacamole, do I want to add habanero peppers, which are very hot, or do I want to add like jalapeno peppers, which are just kind of sort of hot? Okay, do I want to have a lot of interferon and a little bit of IL-4? If that's the case, I'm probably going to get IgG. Do I want to have a lot of IL-4 and IL-10 in that case, I'm going to get IgE, okay? So like this would be like a more prototypical kind of ingredient list to make IgG, whereas like IL-4 plus, say, interferon gamma, now you're talking IgG, okay? So we're using the IL-4 in both recipes. We're just adding other ingredients into the mix as well, okay? The same can be said for TGF-beta, which maybe you get IgE or maybe you get IgG, all right? You can see that interferon gamma pretty much exclusively goes to IgG, and IL-5 pretty much exclusively goes to IgA. And that makes sense because there's a lot of IL-5 in mucosal sites, and IgA is the antibody we want at mucosal sites. So it all works. So really what I want you to get out of this is that cytokines are what are directing this response, and they're doing it very specifically based on how they're put together. Now, let's talk about a way they can get this response. And the way for that to be would be T follicular helper cells. Now, in the notes, I talk about a subset of cells that are T follicular helper cells. So T follicular helper cells are just a specialized T cell, all right? Now, we haven't gone into CD4 helper subclasses yet. Right now, you guys just know that there are CD4 helper cells, but there's actually a lot of different types of CD4 helper cells. There's Th1, which are really pro-inflammatory. There's Th2, which are associated with allergy, and there are TFH cells. These are just CD4 positive T cells that their entire life, their entire job is to hang out in the lymph node and support B cells, okay? This is the home team. They reside in the follicle along with the B cells, and they provide T cell help to them so that they can differentiate. So in this case, the B cell would not need to migrate toward the paracortex to receive T cell help because there's a T cell already there. So as antigens interacted with the B cell and the outer cortex and the follicle, some of them might be degraded. So that's what's happening here, right? This antigen is being picked up by this B cell receptor. It's being internalized, it's being broken up, and it's being loaded onto MHC class 2 here. And then in this case, the B cell is kind of showing the antigen to the T follicular helper cell saying, hey, do you know what this is? Any instructions? What should I do with it? Okay. And there would also be CD40 and CD40 ligand here. And that would result in an increase in expression of cytokine receptors on the B cell so that the B cell could receive the cytokines from the T cell. And then instructions on what kind of antibody to make, be it IgG, IgE, or IgA. Okay, so this is just another cell in our arsenal to support the B cell response that is needed to make antibodies.